Question 3 here is basically a question of, do you understand the definition of the common ion effect? So we've got copper bromide here that is dissolving in a normal KSP equation, and it says here that copper bromide is found to be much less soluble in sodium bromide than it is in pure water. Well, why? Well, we've talked about this before. The sodium bromide is going to break into the sodium ion, which has no effect on this, so I'm going to ignore it, but it's also going to be the bromide. So the bromide is higher than you would normally expect, and so that's going to send it back over to the left-hand side or keep it on the insoluble side, and so consequently, it is not going to be as soluble. So the presence of the additional bromide ions already in the solution means that the equilibrium will be reached when much less copper bromide has been dissolved. That's your guy. Now you might say it's this guy here. You might say that the presence of the additional bromide decreases the value of KSP. That would be wrong. Remember, the only way to actually change the value of KSP is to change the temperature, because K is an equilibrium constant, and so therefore it doesn't actually change anything because it's a constant. So you're not actually changing the value of KSP. All you're doing is changing the numbers that will let you achieve the value of